So our last speaker before lunch, we're running about 15 minutes late, is Ivan Stenius from the Royal Institute of Technology, KTH, in Sweden. Ivan got his master's and PhD from KTH in 2007, is a full-time associate professor at the Department of Mechanics. His expertise is in underwater vehicle modeling, fluid structure interaction, and has been building up a research group in underwater technology and maritime robotics, and is currently the PI of the Swedish Maritime Robotics Center, where he's going to talk about right now. And Ali is setting up, so he's going to present the status of the Swedish Maritime Robotics Center, SMaRC. And without further ado, Ivan, please.
Okay, so thank you very much, and thank you, Bridget, for the wonderful pictures and the presentation. That was very interesting, nice to see. And I'll try to be quick, a little bit quicker now, if I'm the one standing between you and lunch. So, yeah. I'm an associate professor at the KTH, and currently I'm working mostly with the SMaRC Center, and we are now kind of halfway through the process. So I want to give you a glimpse of where we're standing, and also throughout the week here you will be meeting some of our PhD students giving tutorials, and later this week also another colleague of mine giving a lecture here. So we're going to give you a little bit of the background and research results, talk about our demonstration program, and then looking further into the next half of our project, what are our milestones and scenarios, what are we targeting and looking for. And also a little bit post-SMaRC, what happens after this is a project, so at start and an end, and then what are we aiming for in terms of continuing this work. And then hopefully see where can we match up and see if there are any collaboration interests. So to start with this, actually it's not that far back in time that KTH at least did not have almost any underwater technology research or education at all. This is about 10 years ago, 2012, I was meeting some colleagues and also industry and governmental representatives from Sweden in European defense workshops, and we realized that although we have so much coastline, we have an industry depending on engineering technologies for subsea environments and submarines, we didn't have any center or academic node tying together these competencies. And that really sparked our journey to create something like that. And SMaRC and this center that we have now is kind of the state of art that we have at the moment, actually, in terms of that type of center. And it comes also back to that luckily we had many, so apart from me meeting these people, we also had a lot of processes, so we have national agendas, research agendas, that kind of concluded these needs that we had. We also had a lot of different parties, so end users from government, from research, from marine biologists, polar scientists, kind of needing this technology, together with industry partners, developing the technology and needing the expertise. So a lot of kind of factors coming together that really made this happen. And in 2016, SSF, the Swedish Foundation for Strategic Research, they announced this call for centers of excellence and industry research centers. And this was a call targeting all different areas. So there is, at the moment, there are 4 of these centers: medicine and food. And so we were competing with many different proposals. And actually we were the only one that got with an engineering or technical science perspective. And as I said, we're now in the halftime process of the center, and we just passed the halftime evaluation. I think Massimo looking at our progress, and luckily we got a pass, which means that we got the final funding also for the last 4 years. And apart from SSF, that's putting in most of the funding for the project, we have a lot of very committed partners also putting in funding to create this. And we have put them into 3 separate bubbles representing academic partners like KTH, Stockholm University, Gothenburg University, and then industry partners, with the main partner being Saab, and 2 different parts of Saab, which are Saab Kockums, the submarine manufacturer, and then Saab Dynamics, building AUVs, ROVs for offshore and also defense purposes. And then we have a governmental side, mainly constituting defense interests. And those 3 then put together a lot of the co-funding that created the whole center, are essential in terms of building up the center and making us successful in getting the final proposal approved. So this is just an overview of how we have kind of structured the center. And going from the top left corner here, we started with identifying a number of benefit areas or challenges that we faced in terms of taking us to the rightmost corner in terms of next generation. What do we see in terms of the next generation? What technologies, what capabilities do we need to develop to take that step? And in that process we realized we had 4 main research areas, and all of these talks you can see parts of those research areas that's kind of still valid. In terms of autonomy, the intelligence of the systems, endurance, so long-term presence in the subsea environment, perception, understanding your environment that's much different than what we are seeing above the surface, so that's also a challenge. And communication here, by communication, it's underwater communication, of course, that's also a big challenge. So those 4 research areas then built up our targets for what to focus on in the center. And then we wanted to have, and that's why I enjoy coming back here to BtS so much, because all these meetings with students, supervisors, industry, and cross collaboration with engineering sciences and also marine archaeology or biology and polar scientists, that kind of sparks the interests and imagination. And then if you can feed back that into the research projects, then hopefully we get something more than just running along these 4 parallel lines of just research. Then in the bottom half we have a table of number of different projects. So all of these research areas then constitute a number of research sub-projects with PhD students working in different areas, and want them to be able to kind of join together and collaborate as much as possible. And that's why we have this demonstrator program where we develop our own vehicles and we try to get access to other vehicles. So we have access to one of the Kongsberg's Hugin vehicles through Gothenburg University also. So the strategic interest here for the different partners is that all of the different, these benefit areas, they tie together into what they really want to have. So ocean production means kind of looking at what can we use the oceans for. Safeguarding society, of course, defense related, and then environmental sensing, but doesn't really matter which industry part or which benefit area you're looking at. The key capabilities that you need for these robots is actually very much the same. So that's also the motivation for the different partners. We have partners here in SMaRC that has never collaborated before. So defense side, for example, with environmental scientists, they haven't been aware of each other before. And now suddenly they see that they can really benefit and can do something together that they couldn't do before. And these three scenarios, benefit areas, then put together, or we did a study on a first year, looked at how can we kind of craft out the key capabilities that we want to target, and what are the key capabilities that we want these robots to be able to achieve. So that's part of our work that we did, and we generated these three scenarios looking into different aspects of the different benefit areas, and we identified a list of key capabilities. So it's not meant that you can read it, it's more that we had a number of key capabilities with a list of, I think, about 50 capabilities to start with. Then once we started to analyze for the different scenarios, for the different benefit areas, we realized that, oh, it's actually very much the same. So all comprised into some key capabilities that you really want these vehicles to be good at. So then made us also better in terms of focusing on what we need and what we wanted to do, and made the different parties also realize that, yeah, it's very much the same stuff. Doesn't matter if you want the vehicle to go under a glacier in an Antarctic environment, or if you want to sneak peek in the Baltic without being detected. So here is a little bit of some of the achievements, or some stuff that we have done and where we are today. And I'm not going to talk much about this because John Folkesson will talk about this stuff later this week, on Friday, I believe. But it's about being able to use your sensors in a better way, get more out of them by combining sensors with AI, machine learning, and also SLAM techniques for navigation. And these tracks here to the right are from under glacier ice Antarctica expedition 2019. And that expedition actually got also very much publicity, and this was one of the first, or the first one under one of the biggest glaciers in Antarctica that they managed to go in under. And we are also now this year preparing for a next one. So one of our PhDs is preparing to go on board and use data that comes in on the fly to try to make these things more robust. And we talked about risk. I mean, this is very much in line with, you have to cope with the different risks, and how can you design your system so that they can handle that in a better way. And then we have, for our purposes, we have developed our own platforms. So we have two AUVs that we have developed so that we can have access to bolts and nuts and the frames and the code. We can change it. We can have PhD students, we can have master students working on the platforms, and they are allowed to drill holes or do basically any changes they need for their research. So this is, we selected two different kind of targets here. One looking at the bigger platform. This is the bigger one, where we could have larger sensors, we could have larger battery packs, and we could extend the range of the vehicle. We could also allow it to go to deeper depths. And we are now in the state where we actually are doing the first trials with multi-beam sensors on it. And the other one is then going in the other direction, looking at, okay, so how small can we make it so that we can launch it easily, we can bring it with us in the car with basically any equipment. How can we make it as compact as possible? And also look at how can we do tricks with it. We saw pictures about the Norwegian Ilium project, and this is not same, but it's similar in terms of thinking, and that you can use the instability of the dynamics of a vehicle. So imagine that you go backwards with the vehicle. Suddenly you have totally different stability margins. But if you're able to take benefit of those instabilities, then suddenly you can think of, oh, I have suddenly much better maneuvering. I can maneuver in totally different ways. So if you can start exploiting those dynamics, the passive instabilities in the dynamics with your control systems, and then switch between different control logics depending on what you want to do, then you might be able to use the sensors on board in a different way than you could if you had the very stable platform and you only wanted to go straight forward with it. So that's aspects of things that we can explore and test with our vehicles and with our researchers in the project. And this is then the Kongsberg's Hugin vehicle, and it was purchased by the Gothenburg University for these Antarctic expeditions. And we are just a partner in this, and then we can use the vehicle and we can learn, we can see what's the state of the art of what you can do with this type of larger EUVs. And at the moment, so we have tried to combine the different vehicles with simulator environments. So at the bottom row here, you have kind of the hardware layer, looking at real vehicles, how we can integrate them into different types of simulator environments. So want to simulate as much as possible before we go out with them, testing. And then going upwards, we have integrated into the Portuguese, the Neptus software, for example. And we're trying to develop open source, at least open source interfaces. And we have, on the smaller platform, it's totally ROS-based. So looking at how can we kind of extend the capabilities and generate general frameworks and support that generation of frameworks, software frameworks that we can use. And then also utilizing cloud services. So we have started a little bit on doing that. For example, if you want to have an efficient simulator environment that you want PhD students or master's thesis students to be quickly up and running, then we can generate cloud-based computers with everything installed for them, so they get the whole framework with simulators and the software package pre-installed, which makes the process for us to collaborate within the project, but also then of course to do things with others outside the project, also much more interesting. This is just a picture of one of the topics or projects that we're looking at into underwater communications, If you think of 5G, for example, in mobile phones, we start to beam and direct your communication. So this is a little bit similar in terms of underwater, that you actually focus your acoustic energy and communicate in just one direction. And then coming to what we have been also doing quite a lot is try to each year go out, take the whole SMaRC project out into some field stations or some real environments around in Sweden and test the whole system. This is from our demonstration period 2020 on the east coast of Sweden, quite close to Stockholm. And we want to create a place where the industry partners, the academic partners, the governmental partner also can meet in these outdoor environments where we actually test and we show the milestones. We have a set of milestones, so targets that we want to achieve in the project, and we'll try to collect these and show part of what we're doing, and also get feedback from the industry partners during these periods. And this is from this year's. It was on the west coast this year, so we have a number of vehicles there on this picture. And let's see if I can get this one to work. I think this is actually, so we have the CEO of Saab Kockums here. I think we have their chief of research. So this is actually a quite big event for us, and we have good turn up of important people coming within the environment in Sweden here. So it starts to be a very popular event, and we hope to be able to continue that one also. And so far this has been most of an internal SMaRC demonstration period, but now during the second half of the project, I would encourage, and I think we also can be more open and invite the external parties to come and visit us during these demonstration periods. So that could be one opportunity for collaborations, is that we actually share infrastructure and we also share these demonstration periods. All right, so this is the same, but here is another, what we also started to do now, and what I would be interested in seeing, and we saw some pictures from NTNU also about creating these the simulated ocean environments where you collect all the data and also collect, you start building up your simulators with more and more confidence and fidelity. So this is just examples from our simulators where we started to build up this the infrastructure, and also looking at mimicking the topology around that scenario. And we started as part of what we did also to build up this environment at some stage. So building up that type of training sets that you can share and also use in your development of AI strategies in terms of finding things. You have a base map that's the same. Then you have kind of also that ground truth that you can also then compare your algorithms for. So that's part of also what I think could be a good way to collaborate on, is to have part of these shared environments. And then looking also more into the future, I mentioned these scenarios that we have been working on, and all of these scenarios have kind of a touchdown on or base from our partners. And we have now narrowed it down to 6 scenarios looking at the years to come, where 2 of them are focused on different aspects of ocean production. We have 2 focusing on securing the society defense aspects, and then 2 are on environmental sensing, and particularly going up in Antarctic or Antarctica conditions. And just examples of what we look at and what we would like to do is, for example, we have projects at KTH and in Sweden looking at algae farming, building larger algae farms and at the outskirts of our archipelagos. And what type of tools would these future algae farmers use? How do they monitor them? And how do they make sure that they are intact and how do so how they follow the progress of the growth and so on. So we have projects and we want to see how far can we bring the robots in terms of operating in those environments. And key capabilities there will also be same as what you would like for really similar environments with confined spaces, things that change, dynamic scenarios where suddenly you have a rig that has moved a little bit and you don't know when you're going out there exactly how it will look. Also offshore installations, so inspection of all these rigs that were being built in Sweden, also in the rest of the world. There is a lot of things going on, and what type of tools in terms of the subsea resident systems do you need? We are not building, or we're not focusing that much on sensor development, but that's an area that we would like to do much more. So we have limited budget and limited resources. You can't do everything you want, but that's one of the projects that we are doing in terms of that is developing a small Raman spectrum sensor to actually find these micromolar particles in the ocean and see can we trace subjects in the ocean environment in very small quantities. So that's an exciting part. We have long range, so you want to sneak peek and look at things or go undetected for long distances, find things. Of course, very defense relevant. But also if you are restricted by an ice cap above, it's the same thing. You have limited ways of accessing the surface. You have to solve any emergencies that comes up under the ice in terms of securing your vehicle, and sometimes then also the data on board. So at some point maybe your data becomes more valuable than your vehicle in terms of retrieving that one. So it's a matter of securing that you get the mission done and get out of what you want to get out from the mission. Multi-agent systems, of course, you have different types of underwater robots under the surface, so you may think of these subsea resident systems, but also then collaborating with surface and air. We saw a lot of nice pictures also today already about visions of how to do that, and that's very much in line with what we would like to do also, and this is also one of Saab's priorities in terms of getting all of this to work. And then we talked this going into caves and kind of understanding or exploring underwater or submerged caves, and the dynamics of what happens in those situations. Another example of what the scientists are interested in within SMaRC is they want to go close to these calving glacier fronts, and they have a distance restriction with boats, so they can't go close to because of the dangers there, but maybe they can send in these autonomous systems. And that's also a very tricky environment, and designing the systems to be able to cope with drastic and fast changing things suddenly happening. We had actually just a couple of or few weeks ago, we had an expedition up to Svalbard where one of the surface robots was hit by a calving glacier and sank. They were able to retrieve it afterwards, but that's kind of the things that you want the robot to be able to somehow react to and do some quick changes to. And I already also told you about and showed you the interest in terms of doing expeditions into Antarctica and going in under these glaciers, and that's important not only because they are kind of the last white spots on Earth, so we have covered many places, but under these glacier tongues, that's places where we have never been. We don't really know what's under there. So that's important, but also that's a motor for driving the climate processes that happens in all around the globe. So understanding the melting, the warm water inflow, mixing with salt water, mixing with the melting of the icebergs, and that pump and what happens there. That's very important for modeling the climate processes on our planet also. All right, so this is just the final. I'm going to wrap up here. We are looking into the future, so already now, because we realized that when the project ends, that's the end of the funding, and if we have 1 year or so that we don't have that kind of funding that we have now, then people disappear, and knowledge disappears, and things kind of fall apart. So we want to make sure that we can kind of continue. It doesn't probably look like SMaRC as a center right now, but I think that's very important for the Swedish underwater and also maritime robotics community in terms of academic side, that we can continue that process. So that's part of what we also looking into. Different types of collaborations with other research groups, and these are just some ideas about other stuff. I already mentioned kind of the simulators or numerical models to share on data, and then building up testing and infrastructures for proving things in a controlled way, but for harsh and difficult environments. I think that might be also a useful thing to share. And of course, we're open to other ideas and inputs on that. Okay, and there is more also on SMaRC website. There is this halftime report with more details and material, and some also films and movies I didn't show here on what we have been doing. So yeah, please contact me or look for further stuff there. Thank you.
Thank you, Ivan. Are there any questions?
Thanks. Maybe more than a question, some comments, because I revised your work and I really appreciated it because, of course, you had to spend all the first 2 years in building something from scratch.
Yeah.
Then, when you had to start the real work, there was COVID in some way. So we had a small delay, a pause, and so on. And of course, as all these kind of projects, it started with covering everything. Now, I appreciate the fact that now you are focusing on specific topics that are more linked to your, how to say, to your the environment where you work, from the point of view of companies' interests, national interests, and so on. But I have only a quick question about your ongoing networking and collaboration, because when you mention sensors, of course, as in many cases in our community, we are not developing sensors. But have you links with other research groups in different disciplines in Sweden, where they develop sensors for other applications and so on, and maybe they can move this expertise to the marine field?
Yeah, so we have some collaborations with, for example, smaller companies in Sweden developing acoustic sensors, side scans, and we're starting and doing small projects and then trying to see, can we leverage what we have and also extend that. So that's something that we're doing. And then when we're out talking, I mean, as you said, I mean, we're building something from almost from scratch, and we have only so much resources, so it takes a little bit time to build it up, and now I think we are starting to also be able to go out and talk about and get those connections. And all the time, every time I'm going out and talking about this, I mean, you know, you get new input and new connections, and then building up on that. So we have a number of leads, and we have a number of already existing smaller projects, but I think we can do more if we just kind of continue in that process. So I'm happy to extend that. Yeah.
Any more question? So thank you again.
Yeah.